this lesson. Okay, so 3.4 worksheet 8. First of all, at the top of the worksheet, there's a typo. Nothing like starting the lesson off right. At the very top right here, it says the one-to-one property says, and this right, this right here should say, if b to the x equals b to the y, then x equals y, okay? There's a typo. It's not written as an exponent on your sheet. So if we can rewrite things so that they have the same base, then we can just set their exponents equal to each other. Also in this section of the notes, we're going to talk about when you have things you can't write as the same base, like if we have 3 to the x equals 19, can't make 19 a power of 3, right? If it was 9, we could, but if it's 19, we can't. So then we're going to have to take the log of both sides. We did these on worksheet 9A, some of these. We also have some new stuff today that's complicated, so please be paying attention. Can I write these both as powers of the same base? 4 to the x minus 1. Could I make this a power of 4? So I have 4 to the x minus 1 equals 4 squared to the x. And anytime you have an exponent inside and out, what are you doing with these two? Multiplying. So this becomes a 2x. All right, then I have the same base, so I can get rid of the base. So I have x minus 1 equals 2x. If I subtract an x, I have negative 1 equals x, and that's what's on your notes, right? Those are done for you? All right. Can you rewrite? Ooh, yeah, no, this is not that. All right, this is new stuff. This is actually a factoring question, guys, and this is on the quiz, and you have to solve this on the quiz as both an exact and approximate answer. You need both an exact and approximate answer, which means you have to factor it. You can't just graph it or something. All right. Does everyone understand that e to the x squared would be e to the 2x? I need everybody to agree to that first. We good? All right. So this is really an e to the x squared minus 3 e to the x plus 2. Most of you are going to freak out when you see all that garbage and try to factor it. So we're going to do what's called a u substitution. I'm going to make e to the x a u. So this is a u squared minus 3u plus 2 equals 0. Does that feel better? You can solve that? Okay. This looks like something you could solve without having a heart attack, right? So you factor that u plus 3, u minus 1. Just kidding. Holy moly. U minus 2, u minus 1? Yeah, I tried to make it easier, but then I can't factor. Does that look better? Guys? U minus 2, u minus 1 factors u squared is the factor of u squared minus 3u plus 2. So we get u could equal 2 or 1. Did I lose anybody yet? Okay. The problem is we're only halfway done with this. Because what was u really way back up here? So we have e to the x equals 2 or e to the x equals 1. What do you have to do when the x is in the exponent? Log of both sides. If it's an e to the x, do you want to take what kind of log? Gentlemen, I'm going to take the natural log of both sides. All right, what is ln of e? So if we move this out front and multiply it by 1, we just have x. Move this out front, ln of e is 1, we just have x. You just found the exact solutions. Now how do you find the approximate solutions? No one has any idea? Type ln of 2 in your calculator. Somebody do that, quick. ln of 2. Okay, 0.693. Thank you. And this one, you shouldn't need a calculator for. E to what power is 1? 0. So the solutions exactly were the natural log of 2 and the natural log of 1, though this really should just be 0. Okay, but the approximate solution for this ln of 2 was 0.693. All right, we will practice some more of those in a minute. All right, what do you need to do to solve both sides here? I already talked about this one. It's done on your paper, right? Take the log of both sides. As soon as you do that, you can move the x out front. So then you can divide this over here, and you'll have the log of 19 divided by the log of 3. There is no condensing that into a single log. You're just going to type 2 logs and divide it and get an answer. Algebra 1 brain first over here. What do we do first? Okay, we add the 6 and get 7 over there. Then what? Now we have to do the natural log of both sides because the x is in the exponent. Now, as soon as we do the natural log of e, this whole exponent can go out front. Ln of e is what? So this is just 8x plus 1 equals... Now, I don't think the one on the quiz says you have to do this one exactly. What 2 things do we still need to do? Subtract 1 and divide by 8. Everybody good? So if I wrote it exactly, it would say the natural log of 7 minus 1 all divided by 8. But I'm really okay if you just went to your calculator and typed the natural log of 7 and then, was it minus 1? And divided by 8. Okay? And got this answer, which is what the book already did right there. All right, we are going to do these together right now quickly. What can we write these both as powers of? We want to solve this exactly if we can, and these are both powers of 3, so we don't want to do logs. This is a 3 squared, so what do we do with that 2 and the x? Yes, this becomes a 3 to the 2x equals 3 to the 3x minus 4. So then we can get rid of the base because they're the same. If I subtract a 3x off each side, I get a negative 1x equals negative 4, so x equals 4. So if I plug it back in, I'd have 9 to the 4th equals 3. 12 minus 4 is 8. Think that's true? Could you type it in your calculator and check if you wanted to? Yeah, it's true. All right. This is tricky. Guys, what power of 2 is 1/2? 2 to the negative 1, right? Everybody's good with that? Okay, so what power of 2 is this? 2 squared, but put in the denominator, would be 2 to the negative 2. Okay, what power of 2 is 8? 3, and it's in the denominator, so this is 2 to the negative trace, or negative 3. Okay, what are we doing with these numbers up here? Right? You told me earlier when you have this, you do what to those two numbers? Multiply. So I'm going to go ahead and get rid of the base and say up here I have a negative 2 times the 2x minus 1. And over here I have a negative 3 times 11 minus x. Solve that quickly. I got positive 5. Did anybody else get positive 5 eventually? Anyone need help because they're not getting a positive 5? Did I do something wrong? We're good? Okay. One more of these where we rewrite. What can we make these both powers of? So this would be a 2 squared. And this would be a 2 to the what? Negative 1. So then if I get rid of the base, I have a 2 times 3x minus 2 equals a negative 1 times 2x, which would just be a negative 2x. Be careful. What do we get here? 1/2. So if we plug it back in, we'd have 4 to the 3/2 minus 2, which would be 1/2. And over here we'd have 1/2. 1/2 of 2 is 1. Is that true? What does this mean? What does it mean though? 1/2 power means square root. Is that true? It's not true. So what did I do wrong? Oh, wait a minute. 3/2 minus 2 was negative 1/2. My bad. So this should have been 1 over the square root of 4. Is that true? Yeah. That's what I get for trying to check it. We had the answer right at least. All right. This is where it gets painful, but it's on the quiz. As a matter of fact, I think it's on the final exam. Okay. Yes, we're going to do u's. We're going to call this 2u squared plus 12u minus 54. We just have to remember that we're not done until we trade it back for what? E to the x. Our u is e to the x. We're going to have to trade it back. What can we do first? Factor out a 2. Did I do that right, guys? Okay. Can 2 ever equal 0? We could divide that out and it would just go away. What would make this true? U plus 9 equals 0. And u minus 3 equals 0. U would have to be 3. Okay. Algebra 1 kids can solve to there, or they're supposed to be able to eventually. What do we have to now go back and do? This is actually e to the x. Are we done? No, because we need to find e. How do we solve for x? Yes, we have to take the log of both sides. We're going to move the x out front. All right, exact answer. What's ln of e?
1.
So the exact answer is the natural log of negative 9. What do you think? Can you take the natural log of a negative number? Over here, this is 1, so we get x equals a natural log of 3. This is our exact answer. And to get an approximate answer, you just type ln of 3 on your calculator. .0986. Or 1.10. I think it says to the nearest hundredth on the actual quiz, but you could have found that answer right there, by graphing, okay? But you won't get the exact answer, so you won't get the concept right if you can't factor. All right, I know they're miserable, but you got to practice them. All right, can we write these as powers of e or powers of 3 or something? No, so we would just have to do what? Yeah, move the 2x out front. Whoops, so I've become a multiply, sorry. What would that look like if you got x all by itself exactly without using your calculator? What do you have left to do to get the x by itself? Divide by what? By both 2 and the log of 9, right? You don't have to do it in one step. You could do it in 2 if you want. But this is the exact answer. I'm not going to ask you to write that one as an exact answer. Okay, I probably would have done the log of 12 divided by the log of 9, gotten that answer, and then divided it by 2. So I would have taken my calculator and typed log of 12 divided by log of, was it 9, guys? And then I would have said, okay, now I still need to divide that by 2. 0.5655. If we went out several places. Someone else getting that? Or did I round something wrong? We good? Yes, you need a bunch of parentheses. Yes, that's a great question because I forgot to talk about that in this class. If you're going to divide by both of these at the same time, you do need parentheses around the denominator. Otherwise, you have to hit divide twice. Yep. Thank you. Thank you for clarifying. So type it that way if you wanted to get this. Otherwise, you just hit divide twice. What are we going to do first on 6? Please don't say take the natural log because that's what everybody does on the quiz on this question and gets it wrong. What do I always say first? Use your Algebra 1 brain first, right? So we got to divide both sides by 2.4. Isolate the e to the x, as Brooke said. Okay. So I don't know what this is. I don't even want to touch my calculator yet. You can if you want and find a decimal over there. But what are we going to have to do next? Yes. And when we do that, that x minus 6 is going to move out here. So we have the natural log of whatever garbage we had over there a minute ago. What's the natural log of e? So what do we have left to do? Add 6, yeah. So if we're going to type this all in at once, and you don't have to, you can give me a decimal along the way on this one, I don't care. You'd have ln of 9.3 divided by 2.4 plus 6. 7 point something? Someone get that? 7.35 if you rounded to 2 or further. Yes. You can. You can. So what Benny's asking is, could we rewrite this? In the old days, you really couldn't because we didn't have any of those on the calculator. Does that make sense? But now you have a log base 9 button. So you could do log base 9 of 12 equals 2x. So you could do log base 9 of 12 and then divide by 2. You'll get the same answer. Because, Benny, this much of it is just the change of base formula. Yep. Great question. All right. There is no nice way to do this one because 6 is not a power of 3. If you take the log of both sides, you're just going to have ugliness. What's the weirdness over here, guys? You have to do what with this log of 6? Distribute. It's almost easier to just change everything to decimals. Over here, if I type 2 times the log of 3, 2 times the, oh, my calculator's dying. 2 times the log of 3 is 0.954. And over here, the log of 6 is 0.778. But I have to distribute that through here, so I get 0.778x minus 0.778. Then you can just use algebra. Is anybody else getting these numbers? My calculator's about dead, so 0.176x equals negative. Can you get a negative? You can't take the log of a negative number, guys. We're going to talk about some more of those in a minute. Can't take the log of a negative number, but is this a log question from the beginning? Okay. We can put a log back into an exponent. If I do 3 to the power of 2 times negative 4.42, I get 6.06 times 10 to the negative 5th. If I do 6 to the power of negative 4.42 minus 1 on the other side, I get 6.05 times 10 to the negative 5. Actually, this rounds to 6 as well. So all I did was plug the answer back in, both the left and the right, and they came out equal to each other. But the answer is still this. All right, do I need to do 19 or you got 19? 8, number 8. It has a 19 in the problem. You'd have 19x ln of e equals ln of 23. So to get x, you would just do what? Yeah, divide by the 19 and get an answer. All right, moving on. Are we going to talk about logarithms next? Okay, there are 2 kinds of log problems that we have to worry about. Ones where we can get rid of the logs and ones where we can't. The ones where we can get rid of the log use what's called the one-to-one property of logs. It says if you have this, log base b of x equals log base b of y, then x can equal y. You can just get rid of them. But if you can't, if they don't have one log on each side, then you're going to have to exponentiate or convert it back. So if you just had something like this, guys, log base 2 of x equals 7, how would you solve that? Yeah, I would say that means 2 to the 7th equals x, but your teacher last year probably taught you to do that. Okay, which is fine. This will wipe this out and you just get an x, and over here you would have 2 to the 7th power, which is the same thing that I was doing. All right. This problem, algebra 1 first. Can anybody tell me real quick what the steps would be? We'd add 1 over here and get what? 12. And then we'd get rid of this 2, divide it and get 6. And then we would do this. So we'd have 4x equals 5 to the 6th, and then we divide by 4. Is that what they have on your paper? Okay, all done right here for you. Is this the same thing? Can I just get rid of the logs on this one? Anybody know why I can't? Yeah, this miserable 5 right here. So what I want to do is add the log over to the other side so that I have them both on the same side. And then I have to use the properties. Remember, you were thinking that those silly properties from 3.3 are never used. Why would I ever want to condense logs? Here you go. What does plus mean? Times. So I have an x minus 6 times a 2x. Okay, equals 5. What's the base I'm trying to get rid of? 2. So log base 2 goes away. I have a 2x and an x minus 6 that needs to be distributed, so I'm going to write it out in front. What is 2 to the 5th power? 32. Can I do a little magic right here? Can I divide the 2 out first on both sides? Yeah, there's no reason not to. Otherwise, you're going to have to distribute it later and deal with it. So I have an x squared minus a 6x. If I subtract the 16 over here, then it factors x minus 8 and x plus 2. And I get x equals 8 or negative 2, I think. I did that best. All right, go back to the original question, though. Right here, can I put in a negative 2 in either of those spots? Negative 2 minus 6, log of negative number. Nope. Can I put in an 8? What if I got 5? Would a 5 work? No. Positive numbers don't always work, and negative numbers don't always not work. You have to check the problem. But for this question, only the 8 works. All right. We have these. You need to do these with me, right? Okay. What magic do we get to do on 9? 2 log base 10s equal to each other, so we just get to say this has to equal this, which makes x 4. We're done. Can we do the same thing on 10? Not yet. What do we have to do to this? We have to combine these into a single log. What does plus mean I need to do? Multiply. So I have log base 12 of 2 times x equals log base 12 of x plus 7. Now can I get rid of the log base 2 or 12? So I have 2x equals x plus 7 or x equals 7. Okay, now that you're feeling genius. Yeah. They give us a miserable one. It's not really as bad as it looks. And it looks pretty bad. We have to do this plus means what? So we have a 16x plus 2 times a 20x minus 2. And luckily, the first thing we get to do is what? Yeah, drop the logs. Okay, so if I FOIL this together, I have 320x squared plus a 40x minus a 32x and a minus 4. I FOILed that really fast. If I combine like terms, and some of you probably wouldn't even write that step down, because what are we going to have to do here eventually? Yeah, get it equal to 0 so that we can factor it or something. So I got everything over here down to a 0. What's left? Does that factor? So we get x equals 2 or negative 1. Can we keep both of those? On the right-hand side, actually negative 1 would be okay. Because I'd square this and I'd get 319 minus 9 minus 2. But can I put a negative 1 in over here? I'll get the log of negative 22. It's not going to work. So the only answer that works is x equals 2. Anybody stuck? I went fast, I know. All right, let's try a few more. What are we doing on this one? Plus means times. So what do we get on the left? The log of x times x plus 16, or x squared plus 16x. I heard Max. Okay. And this one, we have an 8 times an x plus 6, or 8x plus 48. Did I do that right? Once we were down to a single log, we can get rid of the log. So then I have x squared if I subtract 8x and 48 over here. I still have a positive 8x and a minus 48. Factors of 48 that make 8, guys. So I get x equals okay. Do those both work? No, because it said ln of x, and I can't take the log of a negative number, so this doesn't work. Does a 4 work? Yeah, there's nowhere that that would become negative, so that works. You could type it back in both sides to check it. All right, applications real quick. This says, how long would it take 40 grams to decay to 10 grams? By the way, this is radioactive decay, so it's not going to be quick. All right, so don't be surprised when you get a big number. Where's the 50 going to go? Will it take 50 to go down to 10? So which is the original amount? Okay, A0 is which one though? Yes. So we have 50 e to the negative 0.00043 t equals, and we want it to get down to 10. Isolate, so what happens? Okay, 10 over 50 or 0.2 would be fine, or 1/5. Then what? I'm just too lazy to even write it or do it, because what do I have to do next? Take the ln of both sides, and that will put the exponent out front. This is whatever that's equivalent to is fine. What's ln of e? That's 1. So what do I have left to do to get the t all by itself? Divide by negative 0.00043. So the ln of 10 over 50, close parenthesis, divided by negative 0.00043 is about 3,743 years until this is down to 10 grams. You're definitely going to have application problems on the quiz, on the final. All right, last one. I want you to see if you can do this one on your own. Where are we putting the 6? Magnitude is R, and this is magnitude. So I have 6 equals 0.67 log of 0.37 times some e, and that's not, it's a value, it's the amount of energy, it's not little e. Okay. So isolate the log first. Then what? Still isn't isolated. I still have a log. What do I do now? How do I get rid of a single log, guys? Yes, exponentiate or rewrite what it means. So I have 10 to this power equals 0.37e. So after I type in that 10 to that nastiness, and it's going to depend on how you round along the way, but it's going to be a big number either way. It's about 16 million kilowatt hours of energy. Did someone else get that number? 16 million-ish? Depending how you round it along the way. Okay. The homework is to do page 196 and these applications off 167. You will have time to work on that in class tomorrow as long as you're not doing retakes. If you're doing retakes,